Okay, so let's start. Hey Shivatsav. So good. We have a full house today, except Pradeep. So before we start, tell me if there is any concept that we learned in the previous class that was not clear to you guys. So if you try recalling, right, we talked about the volume and surface area of things like cuboid, cube, right cylinder. I think that's it. And then we briefly touched upon, again, we talked about surface area and volume for these objects. And then let me refer to what I have here. At least I'm just trying to recall what all did we cover, so that okay. So we talked about volume of cuboid, cube and right cylinder. We did not talk about the cone and sphere. That we'll talk about. Then we talked about congruence. Right? We talked about congruence of triangles. What we have not talked about is similarity of triangles. And then we'll also talk about Pythagorean Theorem. So we talked about the parallel lines and the properties. We talked about the volume of cube, cuboid and right cylinder. And we talked about congruence. Any questions with respect to those things that we learned in the previous class? No? Okay. And if there is a question, that's a good news, okay? It's okay to have questions because that becomes your second opportunity to learn something better, okay? Alright, so I'll assume that we don't have a good news, meaning nobody has a question. So let's start with one concept called similarity. Like we talked about congruence, we'll talk about similarity, then the properties around that one, and then we'll go to proving the Pythagorean theorem, and then come back to the volume and surface area for cones and spheres. Let's see what all we are able to cover today, and remaining things we'll cover tomorrow. So let's talk about similarity. What is similarity? And again, in very practical terms, don't give me mathematical answers to begin with. What do we mean by similarity? And what do you know about similarity?
The shapes or the shapes or objects are similar, same.
Say it again.
Shapes or like objects, they have like same size.
Okay, so you said shapes that have same sides or some matching properties. That is one definition which is partly correct. Okay, let's see if somebody else has different definition or different way of looking at it. Again, I'm not looking at any definition as such. Yes, Srivatsava, go ahead.
Same angles and same sides.
Same angles and same sides. Then why are we using one extra term called similar? We can as well call it congruent. That's what we learned in the previous class.
But different sides.
Okay, you're saying same angles but different sides. Is that what you're saying, Jivatsav?
Yes, yes.
You are pretty close. Or I would say, yeah, you're right actually. I would not be shy in acknowledging you being right. Okay. Anybody else having a different way of looking at it? When you say similar, what does it mean? Okay, so when you say similar, okay, similar and same are not exact replacement for each other, okay. If I say similar, I still have a doubt in my mind, and that's why I'm saying similar, I'm not saying same. If I say same, there is no doubt. Yeah. And if you guys are comfortable, okay, I would request you guys to turn on your video so that we can make eye contact and talk, okay? Otherwise, I feel like I'm talking to myself when I see the screen. Okay. Again, not a compulsion, but if you can, that will be better. Alright, so when I'm saying similar and not same, I have a doubt in my mind. And that is what I would want you all to have. Same and similar are not a replacement for each other. Same is same, similar is similar. They are not the same. Okay? Now, what do I mean by that? Why I'm blabbering and repeating the same sentence again and again? Because I want to see that point in your mind that similar and same cannot be a replacement for each other. They are two different words in the vocabulary and they are two different meanings for both of them. Now let's look at the situation. Are these same?
No, sir.
They are not. Are they similar?
Yes, sir. Yes, sir.
Yes. Why? Only if. They'll be similar only if they have matching angles. If I have two triangles similar, then this and this, one angle between both the triangles have matched, second triangle between the two triangles have matched, third angle between the two triangles have also matched. That is the only scenario or situation that will qualify them to be called similar. In other words, in layman's terms, right? I love layman's terms because that is when I can relate things, right? I don't have to think mathematically. If I look at these two things similar, if these two things are similar for me, what does it mean is one of them is a squeezed version of the other one. Meaning, this if you squeeze this one, this, if you squeeze it from all the sides, that is when it becomes similar. I mean, it doesn't mean that two things being similar have to be always squeezed. They can be same and similar both. Let's say this triangle and this triangle can have matching angles, so they are similar, and they can be same also, meaning sides also matching. If sides also matching, then they will be similar and same both. But then, if I am looking at a smaller version of it, like a daddy and son having all same features, meaning all the angles being same, they are similar. When the angles are, only angles are same, they are similar. When angles and sides all are same, that is when you qualify them to call congruent. Yeah? So keep one thing in mind, if anything is congruent, you have no doubt in your mind. So congruent and same are replacement for each other. All the properties are matching. When you say similar, you are very clear with the fact that the angles are matching, regardless of side. Am I clear so far?
Yes, sir.
Yeah? Everybody with me? Now, when you say the triangles are similar, they have matching angles. If you say quadrilaterals are similar, you have matching angles. You take any shape and you call them similar, you are only referring to one property, that is angles. Meaning, between any two shapes, if you say the angles are similar, meaning every angle in one shape has a corresponding matching angle in the other shape. Yeah? You will never say that this triangle and this quadrilateral are similar. They have to be of same sides. Okay? Because this one has 3 angles, here you have 4 angles. If the number of angles are different, even if 3 angles are matching, they will not be similar. Okay? So again, I am talking about all the exclusion scenarios so that you are very clear in your mind when something will be similar, when something will be congruent or same. Are you with me so far? Everybody?
Yes, sir.
I'll keep on nagging you guys just to make sure that I get the confidence that yes, whatever I'm teaching is reaching you all. Teaching and reaching, yeah? Dhanushri with me? Dhanushri, Isha, you guys are with me so far? Everything clear?
Yes, sir.
How about Vaibhav, Sunarka, Athar,
Yes, sir.
Srivatsav, Ludwig, both of you okay?
Yes, sir.
Oh, alright. So far we have not studied anything. We are just wasting time. So we just talked about what is the difference between similar and congruent. So similar, when we say two sets are similar, that means they both have matching angles. Matching number of angles and matching angles. Okay? Now, that information is not enough. Why do I need to know similar when it doesn't solve a purpose? The purpose is this. Or this is rather a property. That if you have two triangles, let's say, which are similar, the first thing that will come to your mind is, yes, they are similar because they have three matching angles. Every angle in one triangle has a corresponding angle of same value in the other triangle. And that is how they are similar. Now, if the two triangles are similar, what geometry says is that if you have two triangles similar, then the corresponding sides will be in the same proportion, or the ratio of the sides will be in the same proportion. Now let's look at this. This is A, B, C, D, E, F. These are two triangles which I am claiming to be similar, okay? Even if you guys have doubt about my drawing skills, bear with me. Just assume that they are similar, okay? I'm not very good when it comes to drawing, so that's why I'm just calling it out. Now, when I say these two triangles are similar, what I'm saying is, and this angle, let's say, is matching with this angle. This angle is matching with the second angle. This angle is matching with this angle. So that is the only reason I can claim these to be similar, okay? Even if they don't look alike. Now, when the two triangles are similar, what property we need to be aware of is the corresponding sides will be in the same proportion. What does it mean? Let's look at this angle. This angle and this angle are same. The side opposite to that angle, which are same, will be in the same proportion, meaning the side opposite to this is what? BC, this one. BC divided by side opposite to this angle is EF. Will be equal to, will be the same, sides will be in the same proportion, meaning this angle, opposite side and next angle, let's say this angle and this angle are same. So side opposite to this one is AC divided by this angle's opposite side is BF. This is what the property says, that if you have two triangles which are similar, then if you take the ratio of their sides, yes, beta.
Sir, I have like good news, sir.
Yeah, tell me.
So like you use this BC by EF and like this proportion for similar or like comparison is like comparison of A, B, C, and D. So you use that for to compare.
We use that for?
Compare.
Yes. So this is what it says. This, I mean, like when we started geometry, right? We talked about shape. A triangle is a closed shape with three sides. And what are the properties? So we have three sides and three angles. These are two properties that we learned when we learned about the triangles. What happened? I see balloons. Okay, I said this and the balloons started popping up. Okay, some AI stuff. Alright, then third thing that we learned about the property of a triangle was triangle has 3 sides and 3 angles. Third thing we learned is sum of all the angles of a triangle is 180 degrees. So these are the 3 key things that we learn about when it comes to knowing the property of a triangle. So same way, the property that we are learning here is when you have 2 triangles which are considered to be similar, or if the 2 triangles are similar, then their sides will be in the same proportion. Okay? So this is more of a property. Only thing that you have to keep in mind is, if I say triangle A and triangle B are similar, that means they have matching angles and their ratio of the sides will be equal. Meaning ratio of these 2 angles are same. What are the sides? This side and this side, opposite to this. So ratio of sides. So this by this side will be equal to, let's pick the second angle. This side by this side will be equal to, let's pick the third angle. What is the side? AB divided by, this is third angle will be equal to, this is BE. So this is the thing that you would need to know. That if I have 2 triangles being similar, the ratios, the ratio of their sides, the corresponding sides will be same. Now let's relate it, right? Now let's relate it. Let's look at this triangle, and inside that let's draw a line parallel to this one. Let's say this was my triangle ABC. What did I do? I picked up a point, let's say E here, and I drew a parallel line to BC here, which cuts this line at F. So now if you look at this triangle ABC and triangle AEF. First of all, you tell me, will these triangles be similar or not? The big triangle and the baby triangle inside that, will they be similar or not?
Yes, sir.
Yes? How?
Yes.
How?
Because the ABC, the triangle is directly equal to small. So the both are like same. I mean like similar.
No, how? How? You have to give me solid reasoning for this one.
SAS.
SAS? No, SAS gives you congruence. That doesn't. SAS, ASA, SSS or RHS, those are theorems for congruence. Congruence meaning exactly the same. Here, you cannot use those theorems for congruence. We are talking about similar triangles. And the only thing that we need to know or need to be aware of before we say so, that if this triangle and this triangle are similar, that means they have matching angles. Only matching angles, no other theorem. Now look at this. If you guys remember the parallel lines, if I have pair of parallel lines and I have one line intersecting both of them, do you guys remember what these angles are called? Corresponding angle. Yeah? Why they are called corresponding angles? Because they are the same side of the line. Meaning, if they are same side of this intersecting line and they are both above the parallel lines. Similarly, this angle and this angle will be corresponding. This angle and this angle will be corresponding angle. Yeah? And from the parallel lines, we know that corresponding angles are same. Why I am asking you guys to recall that? Because here, now if you look at this AEF and ABC, this angle is common in both the triangles. So one angle has matched. 1/3 of the job is done. Now, this angle and this angle are also same. Why? Because these two lines are parallel. That's what I said. And this is like an intersecting line. This becomes corresponding angle. They are same. Yeah? Are you guys with me or I am talking to myself? With me?
Yes, sir.
Sunarka?
Yes,
Isha?
sir.
Everybody with me? I mean, are you able to follow what I'm saying? I'm trying to prove that this bigger angle and in this baby angle inside, bigger triangle and the baby triangle inside that, they are both similar. Why? Because, let me draw a bigger picture so that you guys can relate. This is the bigger triangle, ABC. What did I do? I picked up a point here, calling it E, and I drew a parallel line to BC. I drew a line parallel to BC, okay? Which is cutting this at point F. I said line, it's not a line, it's a line segment, but it's okay. Now, what we are trying to do is, I am saying that triangle ABC and triangle AEF, both are similar triangles. Meaning that this daddy's triangle and the baby triangle, both are similar triangles. That's what we are saying. How? Because this angle is common between both the triangles. So one angle is done. Now look at this angle and this angle. They are also same, because now you recall your understanding of the parallel lines. They are the two parallel lines and this is the intersecting line. The corresponding angles will be same. Yeah? So this angle and this angle are same. This angle and this angle will also be same. Since two angles are already matched, third angle has to match. But regardless, here also we have two parallel lines and this is the intersecting line. Corresponding angles are same. Are you guys with me?
Yes.
Yes, sir.
Clear? Snarka, Rutvik, Isha, everybody? Dhanushri, Athar,
Yes, sir.
everybody? Oh, okay.
Yes, sir.
So, here, now look at this. These two triangles are similar, and what does the property of similar triangles says is, the corresponding sides are the same proportion. Meaning, if you look at this angle is common in both the triangles. The opposite side to this one will be, if I take the bigger triangle, my numerator will be BC, side opposite to this angle. And if I take the smaller triangle, side opposite to this one will be EF. This will be same, this ratio of the sides will be same, because these are similar triangles. That's what the property says. Now, this and this angle are same. So look at this. In the numerator, I have kept the side for the larger triangle. I'll make sure that for numerator, all of the numerators I have side from the bigger triangle. Okay. So I'm picking up these two angles being same. So side opposite to this one. In the bigger triangle, side opposite to this angle will be AC. Divided by, this is the same angle, right? So now pick this angle side opposite to that. In the smaller triangle will be AF. This will be equal to, now you pick the third angle. Again, since we are keeping the side of the bigger triangle as a numerator, we will not change that sequence, otherwise things will go wrong. Now third angle, this one. What is the opposite side? AB. Divided by, this angle same as this one, by AE. Even if I don't say this, right? Even if you don't know this formula, this is exactly what is happening here. I said, like when you have two similar triangles, what you are seeing is, you are squeezing a bigger triangle to a smaller triangle. See? So the ratio of this one, your angles to remain the same. What is changing is only the ratio. If you squeeze it to half the sides, let's say, if I picked up a point here, somewhere halfway through, let's say this E was the middle point of AB. Now, this is what will happen. This becomes, every dimension will become half. This side became half, this side will become half, and this side will also become half. So that's what it is. You, like you do zoom in, zoom out, right? You say increase by 30%. You create a triangle and you say zoom in, increase by 30% or double it to the current size, what happens? The same triangle just becomes bigger, expanded version. Meaning the angle remains the same. That is exactly what happens. Zoom in, zoom out when you are talking about, you are doing nothing but playing with the logic of similar shapes. Be it triangle, be it rectangle, be it anything else. So next time when you play with your laptop or your phone, and when you are zooming in, zooming out, remember one thing, you are playing with the concept of similar shapes, be it any shape. Yeah? Are you guys with me? Everybody? Clear? So far clear, right? I mean, you don't have to say yes if there is slightest of doubt in your mind. Because if we learn it today and we miss something, you have a second chance to watch the video and revise. If you don't do that also, maybe we'll come back to the same concept after 6 months. So till 6 months, if you are missing something, that remains untouched. Yeah? Alright. Can we move on? Yep. Yeah, Babu.
I have a question for you.
Mm-hmm.
So like the proportion is used for the similar triangles?
Yes.
Okay.
So the proportion is only for similar triangles. See, now this will, now for you guys, right, when you do the unit test and all, you will come across a question like this. Saying, this is a triangle ABC. I pick the point, say E, and let's say this distance was, let's say, 6 centimeter, this one is 8 centimeter, and this one is, let's say, 11 centimeter. I'm just making it up, okay? So I pick the point E so that here to here it is 4 centimeter. Now they will say, I have drawn a parallel line here from this point against this line PC, which cuts at F. Now find out the length of this side and length of this side. This is where this concept will help you, because you know this side and this side, ratio of this one. If you know this side, you just apply this formula and you will be able to get it. And this is not a formula. You just start. First thing you will see is, okay, from this point it has drawn a parallel line. So that means there are two similar triangles made here. So my sides will be in the same proportion. And I will use that understanding to derive all the sides. Imagine if we had not talked about this concept, by no means you will be able to find it out. Yeah?
Yes.
Okay. Now, a very stupid question to you all. So, each one of you have the link for the playlist where I'm keeping all these videos, right? Of the class?
Yeah.
Oh, okay. If anybody doesn't have, you will become one of my subscribers. Please subscribe and add that link in your favorites, okay? When you subscribe, it comes in your subscription list, right? That way it will not be difficult for you to find it out. That's the only reason, okay? Even if 10 of you join or subscribe, if you have not subscribed, my subscription count doesn't change much, okay? So don't worry about that. But yeah, to the point that I was making was, it will be easy for you to go and find out these videos from the channel directly. So once you go to the channel, there's a link for playlist. You can click on playlist and there's something called Math Level 3 or SAT, whatever. All your videos are inside that playlist. You don't have to go anywhere else, because there's a lot of other stuff that I'm keeping on the YouTube, but that is not for you guys to worry about. Okay? Alright. So we talked about similar triangles and the property which says if the two triangles are similar, then their sides will be in the same proportion. Now, this concept also helps you prove the Pythagorean theorem. Who all knows how to prove who all knows what is the Pythagorean theorem? And yeah, everybody knows. What is the Pythagorean theorem?
like ABC and like it's A squared plus B squared and C equal to C squared.
Okay. What is ABC here?
So finding out the hypotenuse,
Hypotenuse.
but with the other legs
The other
in a
side.
right-handed triangle.
Right. So basically, if I say that in my own way, I'll say Pythagorean theorem is a theorem that applies for only one type of triangle, that is right angle triangle or right triangle, which says the sum of the squares of the two sides is equal to the square of the hypotenuse. Meaning, if this is my right angle triangle, which one is hypotenuse? The biggest side, or the side opposite to the 90 degree angle. Side opposite to the 90 degree angle. So this is my hypotenuse. I will call it a C. And these are two sides A and B making the right angle. So the Pythagorean theorem says A square plus B square, meaning square of one side and the square of second side, the two sides which is making 90 degree, will be equal to square of the hypotenuse. This is Pythagorean theorem. Okay? Now, Pythagoras said this theorem and he died. Now, if I have to find out what was the basis of this theorem, or if we have to challenge him, why did you do so? Why did you say so? I cannot go to Pythagoras. Can we prove it ourselves? Who all in this class knows how to prove this one? Srivatsar knows. Okay. Atharv also knows. Okay. Mama also knows. Okay. Okay. So many of you know. Now, is it okay for me to do it one more time? Or you guys don't want me to do that?
It's fine, so
We can do it. So I just try being little quick, okay? And trust me, none of you would be asked to prove this theorem by yourself, okay? Ever. But, I mean, at least in US, okay? Had it been India, you would have been asked to. Because that is how I have grown up. We had to even prove the theorems. There are theorems given by some people. Somebody committed a crime and we had to justify it. Okay, so that used to be part of our curriculum where theorems are given and then you are asked to prove it. So that is why I'm just trying to share up with you guys. If you have to, so basically now there is a, I'll just try being quick, okay? I will not prove everything from scratch. I'll just tell you guys or give you guys some clue and then give you a reference of one video where I proved this theorem also, so that we don't repeat the same thing. Now, the way to prove this is this. Again, you'll have to apply the theorem, the concept that we just learned about similar triangles. Meaning, if two triangles are similar, their sides will be in the same proportion. Now, this is my right angle triangle. Okay? A, B, C. And this is the 90 degree angle. What will I do? From this point, I will draw a perpendicular line. It means, let's say D. Okay? So, I had a right angle triangle. I took the point B or the vertex where it's making 90 degree and I drew a perpendicular line on the other side. That means this angle is 90 degree and this angle is also 90 degree. So far it's clear, right? So far you guys are with me? Yeah? Sunarka, Isha, Dhanushri, Atharv, everybody. I know it's post lunch time. I feel very sleepy. So I'm just assuming that you also will feel sleepy if you don't find the class exciting enough. So I'll keep waking you guys up, okay? Alright. So what I have done is I have this right angle triangle. Yeah, Baba. You have raised your hand? Okay. So,
Sir,
yeah, beta.
why did you divide it like into two?
Because I'm trying to prove this theorem. I don't trust Pythagoras, okay? I don't think he was the right guy. I have my doubts in place. I'm trying to see if whatever theorem he has given, it is to be trusted or not.
Okay, sir.
Yeah? So I'm sure many of you would have proved it, learned or seen how to prove it. I'm sure Srivatsa was there in the class where I was explaining how to prove this one. So I'm just trying to do it one more time. So this was my right angle triangle. What did I do was, from this point I have drawn a perpendicular line which is meeting this line AC at point D. Now let's look at triangle. This is my first triangle ABC and I am picking the smaller triangle. This is D, B and C. I have just drawn this again, okay? Because I am taking this baby triangle out and keeping the larger triangle, okay? Now between this triangle and this triangle, meaning the larger triangle and this triangle, they are similar. Do you guys agree or you don't? The large triangle ABC and this baby triangle BBC, they are both similar. Do you guys agree or you don't?
I agree.
Why?
Because the angles are same and the sides are even same.
Size I don't care because I'm saying similar. So I don't really have to worry about the size part of it. I'm only worried about the angle thing. Yeah?
And it's like corresponding.
I'm sorry?
It's corresponding.
Yeah, corresponding angles are same. Meaning this, look at this angle I am saying, right? Between the small triangle and the bigger triangle. They are common, same angle. So one angle has matched. Now, this angle, this one and this angle here, they also have matched 90 degrees, right? So the corner angle is common between both the triangles and this angle are same, 90 degrees, right? So two angles have matched. They have to be similar because sum of all the three angles is 180 degrees. If my two angles have matched between the two triangles, meaning third angle has no choice but have to match. Yeah? Do you guys agree or you don't?
I
And this problem, when we are trying to prove this needs a bit of imagination. That's why I am kind of breaking this into smaller pieces, okay, so that you can visualize it. Okay? And if you have any doubt, it's perfectly fine to ask. If you are keeping quiet, you are not responding back, that raises a doubt in your mind. Everybody okay?
Yes, sir.
Yeah?
Yes, sir.
Okay. So I'm saying this big triangle and this baby triangle, they are both similar because one angle is common between both the triangles and here this angle and this angle are same. So this angle in this baby triangle and this bigger triangle, this angle are 90 degrees. So the third angle has to match. So they are similar. Now if they are similar, if I am talking about triangle ABC and triangle ABC and triangle BCD. Let me do one more thing. Let's point out the angles which have matched. So this is 1, 1, this is 2, and this is 2 here in the bigger triangle, and this is 3, and this one is 3. I just put the right near that angle so that we don't struggle to visualize that. Now, since these two triangles are similar, what happens? The sides will be the same proportion. Let's take the bigger triangle first. So, here, this angle, opposite side to this is AC. AC divided by, I am taking bigger angle, right? So, AC divided by the small, this, okay. This is the second angle, right? Side upper to back. AC divided by BC. So we take the two angles which are same and to the ratio of the sides. So AC divided by this side BC. will be equal to, let's put the other angle, 1, angle 1. Here this is angle 1, this is angle 1. So side opposite to this is AB divided by, here this is 1. Opposite side to that is DB. Okay? And if you pick the third side, third angle, this one. Side opposite to that is what? This is the third angle, side opposite to that. Okay. Will be equal to BC divided by, third angle is this one, opposite side is BC, and third angle is this one, opposite side is DC. So from this big triangle and this small triangle being similar, we got this equation. Okay, let's keep this in our back pocket. Are you guys with me so far? I have done nothing, trust me, I have done nothing complicated. Okay, I had a right angle triangle. I just picked this corner where I have the 90-degree angle, and from there I drew a perpendicular line on the opposite side. So that helped me get two more triangles, right angle triangles. This one baby triangle here, another baby triangle here. So what I am doing is I am taking the big triangle and the baby triangle, one of the baby triangle, and finding out if they are similar by any chance. And we just saw that yes, they are similar. So if they are similar, the sides will be in the same proportion. That's what we got here. Are you guys with me so far? I will not proceed unless I hear a yes from each one of you.
Yes, sir.
Everybody? Everybody? Isha, Tanushree, Carol?
Yes, sir.
Yeah?
Yes, sir.
Oh, okay. Now, see, I'm a teacher and I'm a dad too. Okay? So, I'm a hybrid. So, I'll keep bothering you guys till I get confident. Okay? So, bear with me. Now, here, by taking this small triangle and the big triangle, we found them similar. So, we got this equation. Wonderful. Now, let's look at the second situation. Now, let's look at this baby triangle, meaning this triangle. Meaning A, B, B, here this is 90 degree, and the normal triangle that we have, the bigger one, A, B, C. Okay? Between this triangle and the large triangle, again, this angle is common, meaning this is, I am saying this is 1 and this is 1, both are same angle. Yeah. Again, this is 90 degree and this is 90 degree. So this one I will call 2, this one I will call 2. They are also same. Third angle has to match, no choice. Yeah. So what happened was, this baby triangle is also similar to this larger triangle. Do you guys see that?
Yes, sir.
In summary, what we have seen is, if I have a right angle triangle, from this corner if I draw a perpendicular line, which creates two right triangles, both the right triangles are similar to the large right triangle. Right triangle or right angle triangle. Yeah, that's one conclusion that we have drawn by seeing this. Now, since these two triangles are also similar, same thing applies, their sides will be in the same proportion. So let's write it down. Now pick angle 1. This angle and this angle are same. Side opposite to that. First I will pick the bigger triangle. Okay? ABC, the bigger one. Side opposite to 1 is what? BC. BC divided by side opposite to 1 is this one, BD. Will be equal to this. Okay, angle 1 we have taken. Now take angle 2 in the bigger triangle. What is side opposite to that? AC. AC divided by, pick angle 2. And side opposite to that is what? Is AB. Now pick angle 3 in the bigger triangle. Side opposite to that is what? AB. Take the third angle here. Side opposite to that is AB. Okay? Now let's break it down. Now you look at this. Okay, I will take the things that help me get a square. So here in this equation, AC by BC equal to AB by DB equal to BC by DC. What I will do is, I will pick this and this. So I pick AC by BC equal to BC by DC. Why? Because it helps me get a square of BC. BC is nothing but this side. Okay. Now similarly here also in this equation, I will pick the one that helps me get a square. I will pick these two. Okay. AC by AD. This is one equation for me. So what I will do is, okay, now let's simplify this. This one. AC, okay, let BC go on one side. BC into BC will be equal to this AC into BC. Are you guys with me so far? I just simplified this part, okay? I made BC go on one side, so division here becomes multiplication by going this side. Division here becomes multiplication this side. So BC into BC equal to AC into BC. Okay? Are you guys with me?
Yes, sir.
Okay, now this means BC into BC is what? BC square equal to AC into BC. Okay? Now this is one thing we have got. Now let's go to, let's take the second one. So here I was saying I was picking this one, which gives me a square again. So see, I did not do anything great. What did I do was, I picked up this equal to this equals to this, meaning A equal to B equal to C. I can choose A equal to B, or I can choose A equal to C, or I can choose B equal to C. I had interest for these two. First one, A and C. I picked these two because this is giving me a square. Okay. Similarly here also I picked up these two because this is giving me a square. So AC by AB equal to AB by AB. One thing we have got already, okay? Now, here this gives me AB square, meaning this goes here and this goes here. Or I'll say this here, okay? So AB square equal to AC into AB. So here I got BC square, as in this one, equal to AC into BC. And then AB square, as in this one, equal to AC into AB. This is what I got. Are you guys okay with whatever we have seen so far? Everybody? And I'll summarize this. So there's nothing to worry, okay? And now we have essentially got two equations. This one says BC square equal to AC into BC, and second equation we got was AB square equal to AC into AB. Okay? So these are two equations we got. Now what Pythagoras told us and died was this, that A square plus B square equal to C square, and he left us clueless, right? We cannot go and challenge him now. So that's why we are trying to prove it, okay? I know that's a bad joke, but still, bear with it. Now, so let's say this is AB square. If I call this as A, and this call it B, and this whole line call it C, that is what the Pythagorean theorem says. A square plus B square equal to C square. Now, I am not substituting these values, okay? Right now, let's look at this. So BC square, meaning this square plus this one. I am just adding these two equations, okay? Plus AB square equal to what? AC into DC. This is BC square plus this AB square value is AC into DC. Are you guys with me so far? I have done nothing. We got two equations. I just added them together. That's it. Yeah. Everybody with me, right? I'm not making you guys sleep, right? Am I?
Yes, sir.
Okay. Stay awake. This is something that we don't learn every day, okay? Now, so BC square plus AB square equal to AC into DC and AC into DC. What did I do? BC plus AD is equal to AC into BC. BC is equal to AC into BC, and AD squared equal to AC into AD. AC into AD. This was my equation. Now, that means BC squared plus AD squared equal to, here AC I can take common between both. BC plus AD. Yeah. Here I took AC common, become BC, and then here I took AC common, I am left with AD. Are you guys okay with what I have done here, right? This is clear? I just took the common out, okay? Yeah?
Yes, sir.
Now you look at this carefully. AD plus BC. AD plus BC. How much is that? AD plus BC. How much is that? AC into AD plus BC. AD plus BC is how much? AC, right? AD plus BC is AC, right? AD plus BC is AC. Yeah?
Yes, sir.
Yes, sir.
That means I can say this as AC squared. So my equation became BC squared plus AD squared equal to AC squared. Now BC squared is what? BC squared is B squared. We are giving this a name B. Plus AB squared is what? A squared. Equal to AC squared. See, this is B squared, this is A squared, and AC is what? C. AC is C. So B squared plus A squared equal to C squared, or A squared plus B squared equal to C squared. Just splitting it. So summary of all that circuit that I was doing for last 10 minutes was this. We had a right angle triangle. We just drew a perpendicular line from here to the opposite side, and that converted this into two additional right angle triangles. When we looked at these triangles against the larger triangle, this baby triangle was similar to the larger triangle. This baby triangle was also similar to the larger triangle, and that is why when the triangles are similar, their sides are in the same proportion. We got these. From that we picked up the two combinations which are giving me a square, and that is how I got AB square plus BC square equal to this. Just by simplifying them, and then adding them gave me this. This is nothing but the AC. So that became AC square. So B square plus A square equal to C square. So we don't really have to curse Pythagoras for giving us this theorem. We have seen it ourselves that this theorem is to be believed. Pythagoras was a good guy, no question about it. Yeah?
Yes, sir.
So respect Pythagoras because he gave a right theorem, okay? Yeah? Alright. Who joined? I think, a third joined from two devices. Okay. So here, what we saw was the correlation between the property of similar triangles and how does that help us in proving the Pythagorean theorem or Pythagorean theorem. Are you guys clear, or have you understood what I did? If there is any doubt, I can repeat.
No, sir.
Yes, sir.
Dhanushri, Isha and Sunarka, you guys are more quiet, so that's why I'm asking you guys again. And Rutvik also. Everybody clear?
I got it.
Yeah, okay. So, now I have muddled the water so much so that it will take you guys a lot of effort to forget what the Pythagorean theorem is. Right? And that is exactly what math requires us to do. You have to keep muddling the water, meaning whatever concept you learn, you apply it, you keep dragging it, you keep stretching it to an extent that by no means you will forget this. And even if next time when somebody says, okay, Pythagorean theorem, first thing that will come to your mind is this image. And Vaibhav, like you asked me in the beginning, why are you drawing this perpendicular line? Now you will relate that with your question also, that one old guy was drawing a triangle on the board, and then I asked him, why are you drawing the perpendicular line? Now I know the reason was that he was trying to draw two child triangles which are similar to the parent triangle, and based on the similarity of the triangle concepts, we found the sides will be in the same proportion, and if they are in the same proportion, we just exploded that to get this equation, which makes us believe that Pythagoras was the right guy. I know I should not be saying that. Those people are much more respectable. I was just trying to add some fun element to it so that you can relate and you can remember for a little longer time. Yeah? Everybody with me so far?
Yes, sir. Yes.
So basically whatever we have learned today so far, that helps us to do two things. Similar triangle properties, that will help us find out the unknown dimensions for the shapes when you are given, let's say when you are given two shapes, two triangles or two quadrilaterals, and some of the dimensions are given, some of the dimensions you have been asked to do. What will be your approach? First thing you will look for is congruence. That do they have all the same matching properties? No. Okay, if they have matching sides, then we are talking about congruence. If they have matching angles alone and sides don't seem to be matching, then we are talking about similarity. That is where the ratio comes into play. Right? So when you get a question where you have to find out the unknown or missing dimensions, you have to try relating that with either the concepts of congruence or similarity, and then if you are talking about congruence, it's easy to relate. You just have to match it using the theorems that you know, the four theorems, right? Or if you are talking about similarity, then if the only thing that is visible or known to you is by only the angles and one of the sides, then you can try relating with that the proportion concepts, and then you should be able to solve it. Okay? So we covered that part, and we talked about the Pythagorean theorem also. And the question that you'll get from Pythagorean theorem will be much more straightforward. You'll have two sides given, third side you have to find out. Yeah? And Pythagorean theorem applies only for right angle triangle. So that also we'll keep in mind. Any questions? I think we are already top of the hour. We have just 2 more minutes before the smaller kids start joining. Any questions that you guys have?
No, sir.
No?
No,
Yes?
sir.
And I believe you guys start doing assignment from the previous class that we did. Anybody struggle with any questions? Some of you had reached out to me with some questions that were not easy to do, and I tried solving them. But I would want you guys to have face problems when doing it, right? And the only way you would face problem is when you actually do it, right? So do the sums, do the unit test, face some problems, and that is where we'll become, obviously I'm too old to become friend with you guys, but we'll have a little more connection, more opportunity to interact, right? Do the problems, struggle with the problems, try to do some complex problems, something that makes you believe that you understood the concept, or you have something that you still have to learn. Okay? Don't assume that attending the 1 hour class would be enough. You have to do some sums, and you have to try failing a couple of times. If you fail, that becomes an opportunity to learn. Yeah? So feel free to ask questions to me. Send those questions to me, say, okay sir, this one we could not do it. I'm kind of struggling solving this one. Can you help me solve this problem? And things like that. And then that is the way we'll be able to practice those. And if you guys are comfortable, share those questions in the WhatsApp group itself. Say, okay, I found this problem, I was struggling to solve it. Can you help me solve this? Is anybody in the group able to solve it in a better way? Because your scores are going to be your score, okay? No matter who is solving it. So ultimately this group should benefit each other. Try doing that and let me know if you face any problem. Okay? With that, we'll end the class for today. Unless you guys have anything for last 1 minute. No? Okay. So enjoy the rest of your evening. See you guys tomorrow. Yeah? Alright. Yep. Bye bye. Take care.
Bye, sir.
Yep. Bye bye.